Okay, let's start. Today now, yes. You mean the previous one that you asked me about? Okay, keep it for the next period today. I will write it and you will solve it today with each other. Okay. Now, today we will start with the next lesson, chapter 8. Which is the reciprocal, I'm sorry. Which is the reciprocal function family. In the previous lesson, we talked about the inverse and the direct variation and to differentiate how can we find the function. Oh my God. Yes. Sorry, please. Yes. I'm sorry, girls, for wasting the time. I don't know what's. Okay. Now, I'm so sorry. Today our lesson is talking about the reciprocal function family. In the previous lesson, we talked about how can we differentiate between the inverse and the direct variation. Now, from here, we have to know that the inverse variation, as we said yesterday, it is y equal k over x. So this is an inverse variation. And this type of variation is a family, is a type of reciprocal function. Why it's a type of reciprocal function? Because it's belong to the parents, or it's belong to the reciprocal function 1 over x. Just like it's k over x, or a over x, or 4 over x, or 1 over x. They are from the parents of the function 1 over x. So the inverse variation is a type of reciprocal function. Is there a girl trying to join us? Lama and Lana. No, Sarah, she's unknown user. She's with us. Okay, back now. And Yara. Yara, Lama, Lana. Why are you late? So the inverse variation, it's a type of the reciprocal function. It can be written as 1 over x because the reciprocal, it is k over x, and it can be written as 1 over x. Now, so the parent of the reciprocal function, as I said, it is 1 over x. And this is what's shown here. Oh, this is as is shown here. But now, the general form of the reciprocal function is, we know it is a over x. But here, if there is the asymptotes is x-axis and y-axis, we can write it as a over x. But if the asymptotes is not on the x-axis or on the y-axis, it's in another place, we add negative h minus h, sorry. So it will be a over x minus h plus k. This type of reciprocal function we will talk about next period. Now today, I'm sorry, this in class we are talking about only y equal 1 over x. We are discussing how can we draw its graph, how can we find its asymptotes and the domain, the range, and the the y and x intercepts. So I will repeat, this y equal 1 over x, we called it the parent of the reciprocal function. It is the general, or this is the parent of it. The general form of the reciprocal function is y equal a over x minus h plus k. Let's now start with how can we graph the inverse variation, which is yes. If it is inverse or reciprocal variation, reciprocal function. Yes. No, two quadrant. Okay, now let's start. If we have now here y is equal 8 over x, and I want now to sketch the graph and want now to identify the x and the y intercepts, and I want now to find the asymptotes of the graph and state the domain and the range of the function. Y equal 8 over x. I want to sketch any graph. As we said before, we have to plot a values for x and y. 1, 2, 4, 8, and also we will choose a negative values like -1, -2, -4, and -8. At point 1, we will say 8 over 1 is 8. I will substitute with x instead of, with 2 instead of x. Now 8 over 2 is 4. 8 over 4 is 2. 8 over 8 is 1. 8 over -1 is -8. 8 over -2 is -4. 8 over -4 is, I'm sorry, over -4 is -2, and 8 over -8 is -1. So here we have the plot of the numbers here. Now, we are going here now. So after I plotting now the values as you see here, and if you continue, if you put as an example 0.5, it will be 16, and if you put 0.25, it will be 32. If you put -0.5, it will be -16. If you put -0.25, it will be -32. Now, as you see here, after we plotting the points, so after we plotting the points now here, we are connecting them to see what the graph will be. So after you connect them, it will be like this, and it will be like this. And as you noticed here, it will not touch the x and the y axis. So this is now the graph of 8 over x. Okay, now I want now to identify the intercepts. What is the meaning of y-intercept? Yes, so I will ask myself, look at this graph. Is the graph touch the y-axis? No, so I will say that there's no y-intercept. No, no. 0, it's touch the x-axis, the y-axis, sorry. Now what about the x-intercept? Thank you. I will ask myself now, is my graph touch the x-axis? No, so it will be, there's no x-intercept. Now, I will ask, they asked me also about to find the asymptotes. What is the meaning of the asymptotes? The asymptotes Yes, please. I cannot answer you. I cannot hear you, please. Okay. Yes, it's a line that comes very close to the curve, or kind of like this. So this is now the asymptotes. Now, what is the vertical asymptotes? The vertical asymptotes, yes. Look here. We have the vertical asymptotes. What are? Yes, so the vertical asymptotes is the y-axis. I will change. So the vertical asymptotes is the y-axis, and the horizontal asymptotes is the x-axis. Sorry. Now, they asked me also to state the domain and the range of the graph. Look at this graph here. Look at the x-axis. Oh, I'm sorry, the values of x. Can we have a value of x at point -1? Yes, at point -2, at point -0.25. Exactly. I can't find any y at any point of x except 0. So I will write the domain here. I'm so sorry today. I don't know what's up with my laptop. Everything is very bad. So the domain here, I can write it as all real numbers except 0, or you can write it like, look at the values of x here. It started from -infinity and it stopped at 0. Then it will continue from 0 to infinity. So I can rewrite it as from -infinity to 0 and from 0 to infinity. You have to know that. Can you repeat? Why is? Okay, because can you say 8? Can you here you have the function is 8 over x. If x is 0, is there any number that's equal 8 over 0? It's undefined. 8 over 0, it's undefined. So it cannot all real numbers except 0. Yeah, I can say -1. I can say -0.25, but I cannot say 0. All real numbers except 0. Now, okay, so now I will rewrite it as from -infinity to 0 and from 0 to infinity. Now you have to know that also at the infinities, you must write it as an open interval, and also at 0, you have to write it also as open interval. Why? Because 0 is not included. I must write it as an open interval. If it is the 0 is included, you can write it as closed interval. So this is now for the domain. Now for the range. Look at now the y values. The y values. Yes, I can see that y, it could be 1, 2, 3, negative 0.25, any number. So I can say the range here is all real numbers except 0, or also I can write it as from negative infinity to 0 and from 0 to infinity. Now, if you have this graph now, if you have this function now, y equal 12 over x. I want now to sketch the graph. I want now to identify the x and the y intercepts, the asymptotes, and the domain and the range of the function. Now, if it is 12 over x. So if x is 1, y is 12. If x is 2, y is 6. If x is 3, y is 4. If x is 4, y is 3. If x is negative 1, it is negative 12. If x is negative 2, it will be negative 6. Negative 0.5, it will be negative 24. What also? Negative 0.25, 12 times 4 for negative 48. 0.25, it will be also 48. This is now as you see here, the first graph with the purple color is for 8 over x. Can you see it? Look here, it is with this one is for 8 over x. And the second one is for yes, I keep it. I want to keep them, but I don't know. If you connect now the green points, it is for 12 over x. And if you connect now between the purple one they are for 12 over x. Oh, sorry, they are for 8 over x. Okay, so look here, 8 over x. as I can, like that, I multiply it with 12 over 8 is 4, or 6 over 4. Like I multiply it with 1.5. So look here, is it shrink or stretch or reflect or what? It's a stretch. Thank you. Because as you see here, 8 over x, if I multiply it with 1.5, with a factor of multiple 0.5, it will be 12 over x. Because of that, because the 8 will be increased to 12, and say it is stretch. Now, if I draw now, no, I told you that, no, how can I make 8 over x to be as a 12 over x? By multiplying it by 1.5. Since I'm multiplying it with a number that's greater than 1, it will stretch. As see, Rose, I will classify it next period, but just an introduction here. There's many questions how to tell you that it's shrink or stretch. But just here on the graph, I want to let you to see that if I have 8 over x and I want to draw 12 over x, since I multiply 8 over x with a number that's greater than 1, with a factor that's greater than 1, the graph will stretch. How can it will be? I will now want to add 0.25 over x. Okay, here now I want to draw 0.25 over x. If x is 1, the answer is 0.25. If x is 2, it will be 0.125. Try to focus with me, okay? May I make wrong? If you try 4, 1 over 16, how it will be? Where's my calculator? 1 over 16. Can I write like this? Yes. Oh. If it is 0.25, it will be 1. Now, if it is negative 1, it will be negative 0.25. I'm sorry. If it is negative 2, it will be negative 0.125. If it is negative 4, it will be negative 1 over 60. Now, look here now, please. The first one, it was 8 over x. Okay, and also in the third quadrant. If I want now to put or to keep 0.25 over x, how the graph will be? Look here. So this one is for 8 over x, and this one is 0.25 over x. So here, did I multiply 8 with a number that's greater than 1 to be as 0.25? Or I divide it, or I multiply it with less than 1? Since I multiply it with less than 1, so the shape of the graph will be shrinked. What about now, if the function now is, it will be like, as an example, negative 8 over x. Thank you so much. So here, negative 8 over x. If it is 1, it will be negative 8. If it is 2, it will be negative 4. If it is 4, it will be negative 2. If it is 8, it will be negative 1. Tell me if I made anything wrong, okay? Negative 1. It's negative 8 over x. I want to sketch negative 8 over x now. If it is negative 2, it is 4. Negative 4, it is 2. And negative 8, it is 1. Now look at this graph here. So the first one, now I will draw 8 over x with the red color. This one is for 8 over x. Now, what about now negative 8 over x? Now, as Hanin said, the graph or the function will be what? Reflect. Why? Because I multiply it with number that is less than 0. It is with negative 1. So, here, it was here and here. So it will be reflect. And for the values, it will be here. And also it will be here. This one for the negative 8 over x. Now, these types of reflection, shrink, and the translation, all of them, we will discuss it, inshallah, next period with the problem 3 and 4. But just here, I want you to see, using the graphing calculator, how if I put 8 over x, 12 over x, 0.25 over x, negative 8 over x, how the graph will be. Now back to our slides now. So now here we draw 12 over x, and we draw it before that. We said how it was, how it will be. It was like this and this. This is for 12 over x. Now, how can I find the x and y intercept? I will ask myself for this graph. Okay, for this graph now, what is the x-intercept? There's no x-intercept because I will ask myself, is my graph touch the x-axis? No, so there's no x-intercept. For now, the y-intercept. Is the graph touch the y-axis? Also no. So I say there's no x-intercept. There's no y-intercept. What about now the domain? Here. It is all the real numbers except 0. What about now the range? So girls, any function from the parent of a over x, if it is 0.25 over x, 8 over x, 12 over x, 1 over x, any function like a, it like b on a over x, all the time the domain is the same, it will be from negative infinity to 0 and from 0 to infinity. The range will be also the same from negative infinity to 0 and from 0 to infinity. It have also the same x and y intercepts, and it had their asymptotes is the same. The vertical asymptotes, it will be the y-axis, and the horizontal asymptotes, it will be the x-axis. Now, in this problem, we sketch it on the graphing calculator. Here, if you have 1 over x, we know how it will be. But what about if it is 6 over x? I told you, since we multiply it by a number that is greater than 1, so it will stretch. But if I'm multiplying it now with a 0.25, that's a, or the number that I'm multiplying with it, is it less than 1? Because 0.25 is it is less than 1, so it will be shrinked. And for the third one, it was a, it is negative 6. And since it was negative 6, is it right? Yes. And since now I will ask myself if the negative 6, it is less than 0? Yes. So it will be reflected.